Hi friends, good morning. Am I audible? Good morning Arun and good morning Prachi, good morning Narendra. How are you? It's been 2 days that I have completed traffic engineering in transportation engineering. We have completed 3 subjects till now. First one is traffic and three chapters: traffic, highway, and the first one is what, introduction, right? Now we'll be seeing design of pavements. Design of pavements. Design of pavements. If you remember, uh, I have not discussed this with you. In design of pavements, there are two types of pavements. First one is flexible pavement. And second one is rigid pavement. Flexible pavement and second one is rigid pavement. In design of pavements, the two things that we'll see is flexible pavement and rigid pavement. And the name itself says flexible pavement means it has more elastic nature. It has very less elastic nature, and failure over here you will see the failure as brittle failure, where here you will see ductile failure. Normally whenever we are designing the highways also, we are going for composite thing, that is flexible bituminous course over the cement concrete roads. Fine. So that we will be having both strength, and the failure will also be in the form of ductile failure. We generally prefer ductile failure. Why we prefer ductile failure? Because it gives you indication before the failure, whereas brittle failure, it will not give you indication, it will directly fail, right? That means if you take normal beams or anything, if there will be huge amount of bending before failure, there will be huge amount of bending, whereas here there will not be any bending, it will suddenly fail. So you will see sudden failure in brittle pavements, whereas you will see some indication before the pavements. Before the failure you will see some amount of indication over here. That's why that is the major advantage of flexible pavements, but the strength is very less in the flexible pavement compared to that of rigid pavements. So if we see the differences, actual differences between flexible pavement and rigid pavement, flexible pavement and rigid pavement. If you see the differences, first the major difference you will see in the cross section. Subgrade, subbase course, base course, surface course. This is how you will see generally the flexible pavement, cross section of flexible pavement. Subgrade means indirectly soil. On the soil there will be subbase course, like very weak type of the better material than gravel. Subgrade means indirectly soil. On the top of the soil, the grain size which is more than that of the soil, you will provide in subbase course. In base course you will provide some amount of bigger size gravel, and in surface course you will be providing bituminous indirectly. This is how the cross section looks like: subgrade, subbase, base, surface course. Whereas in rigid pavements, there will be only three things generally. So here you will see subbase or subgrade, base course, and there will be surface course. Sometimes you don't see base course also. Sometimes you don't see base course also. You will see only subgrade and surface course. It's indirectly like there will be soil. On the soil, you will be constructing concrete slabs. Recently, you might be seeing in the highways. Initially, the soil will be compacted properly. On the top of the soil, there will be concrete slabs. So this is the cross section of the rigid pavement. This is cross section of flexible pavement, and this is cross section of rigid pavement. Fine. And if you see here, there will be low or negligible flexural strength. Low or negligible flexural strength. And there is high flexural strength over here. Flexural strength means bending strength, right? So there will be high flexural strength. See, the strength is more here, strength is less here, but elasticity is more here compared to that of here, right? That means if it has to expand, it expands and it can easily come back like this in flexible pavement, whereas in rigid pavement, that type of thing you don't see. If there is some failure, it breaks, brittle type of failure I am saying over here, right? So that is what you will see here, and there will be some more elasticity here. So low or negligible flexural strength, and there will be high flexural strength over here. Next one is load is transferred by grain to grain contact. Load is transferred by grain to grain contact, and load is transferred through slab action. Slab action, that means it behaves same as that of the slab, or normal slabs, how it behaves. In the same way, load is transferred through slab action, whereas load is transferred through grain to grain contact. Over grain to grain means from bitumen it will be transferred onto the gravel. From this gravel it will be transferred onto this soil. From this soil it will be transferred onto the final soil, that is final ground. It will be transferred. So grain to grain contact, like means load will be transferred onto this grain, and from this grain it will be transferred onto this grain, and like this is grain to grain contact. Okay, so load is transferred between from grain to grain contact, whereas here it is whole slab. So load is transferred, this is like a concrete slab. Load is transferred by whenever your this bending action you will be seeing. Load is transferred by the slab, like saucer type of bending, whether it is one-way slab, two-way slab. Based on that, there will be some saucer. Your teacup saucer will be there, right? That type of bending you will be seeing. So that type of thing, load is transferred through slab action, and here it is high. These are the things that you generally see. Code. The code generally used for design of flexible pavements is IRC 37-2012, and code generally used for rigid pavement is IRC 58-2012. IRC 58-2012, and here you don't see any joints. Joints are absent. Whereas here joints are present. Joints means joints are present. Joints means, like rigid pavements are constructed something like this. This is concrete slab, this is another concrete slab, this is another concrete slab. So for expansion and contraction, you will be providing certain amount of joints, which is also called as expansion joint, contraction joints, construction joints, different types of joints. Okay, expansion joint, contraction joint, construction joint, and different types of joints you will be seeing. So this will be like, you know, rigid pavement, different slabs, and there will be joints, 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 joints. All these joints you will be seeing over here. So these type of joints are considered as these type of joints you will be seeing in the rigid pavement. All these things will be seen in rigid pavement. Rigid pavement, whereas in flexible pavement you don't see all these joints. The road will be constructed like, you know, whole thing as single unit. The roads will be constructed. So joints are present here, joints are absent in this case. Fine. And next point would be, if there is any failure in the lower surface, it will be visible in the layers above it. It will be visible in the layers above it. If there is any failure in the lower surface, like, you know, if there is any failure in the surface course, so if there is any failure in the subgrade, it will be visible in subgrade, base and surface course. Like, you know, if there is any subgrade, there will be any, like, you know, if it goes down, or if there is any contraction, if there is any settlement over here, it will be seen up to the top surface also, like, you know, it will be bent like that. The whole road will be bent like that. So that is the meaning of it. If there is any failure in subbase, it will be seen in base and surface. That is the meaning of it. If there is any failure in the lower surface, it will be seen up to the topmost surface. Fine. Next one is and here in rigid pavement, if there is any failure in subgrade, it will not be seen in surface course. Why? Because if soil settles over here, the slab will be like that only, slab will not bend. Whereas here, since there is contact like this, it will bend, but the slab will be like this. If soil settles also, slab will be like this only, it will not bend. Slab will be perfectly horizontal. So the localized failure can be contained. That means whatever the failure in the subgrade cannot be seen in the surface course. That's what you can write over here. Localized failure is contained. Localized failure is contained. That is any failure in the lower surface, is not seen in the above layers. Any failure in the lower surface is not seen in the above layers. So these are the different points that you should keep in mind. There are many more points also that I will discuss. The major points, if they will not ask you what are the differences exactly between the rigid pavement and flexible pavement in the examination. These points can be asked in the form of assertion reason, or, you know, some multiple choice questions in your engineering services prelims. Any doubts in this, you can ask me. Yeah, good morning madam, good morning Nitya madam, and good morning Prachi. There is one dislike, thanks for disliking me. Any doubts in this, guys? Any doubts? No doubts? Fine. You can add one more point if you want to, that is here, if I talk about cost, low initial cost and high maintenance cost. Low initial cost and high maintenance cost. High initial cost. High initial cost but low maintenance cost. High initial cost but low maintenance cost. So these are the things that you generally have to points that you have to remember. Next thing that you can see over here is, apart from this, conventional, this is flexible pavement, this is rigid pavement, there are other types of pavements. First one is composite pavement. Composite pavement. Composite pavement. In this pavement, in this type of pavements, bituminous layer is provided over cement concrete course of rigid pavement. Cement concrete course of rigid pavement, so that it can provide smooth riding facility. So whatever the constructions, highway constructions that recent highway constructions that you are seeing, in this you will be providing the bituminous layer over the cement concrete course of rigid pavement. So this is the latest version. On this there will be subgrade, there will be cement concrete course. On the top of the cement concrete course you are going to provide the bituminous layer. So there will be advantage of both rigid pavement and flexible pavement over here. So that is the major thing that you should remember over here in this one. Okay. Okay, that is composite pavement. Next one is semi-rigid pavement. Semi-rigid pavement. Semi-rigid pavement in this types of pavements the subbase and base course of flexible pavement, the subbase and base course of flexible pavement is replaced by cement slurry or soil cement mix, which is also called as soil cement mix. Sometimes you can also use fly ash and all those things also, fly ash aggregates and all those things also. Why we are replacing it? In order to increase its flexural strength. In order to increase its flexural strength. So the flexural strength of semi-rigid pavement will be in between will be in between flexural strength of flexible pavement and flexural strength of rigid pavement. That is the range. Flexural strength of semi-rigid pavement is in the range of flexural strength of flexible pavement and flexural strength of rigid pavement. This is semi-rigid pavement and this is composite pavement. Okay, so these are the different types of types of pavements. And generally, if you see failures, you can take a note. In flexible pavements, fatigue and rutting are considered as failures. Fatigue and rutting are considered as failures. And in rigid pavements, fatigue and mud pumping are considered as failures. Mud pumping are considered as failures. Fatigue means what? Fatigue means not R-E-U-E. Fatigue means, you know, if there are repetition of vehicles, huge amount of repetition of vehicles, it because of heavy load or the same load repeating for n number of times, like, you know, endurance limit you might have seen in your strength of materials, where the same load is being applied for n number of times. If you can take this load, if the same load is being applied for n number of times, at one point this fails, this whatever the pavement, that fails, that is called fatigue. So major failure criteria is fatigue in both the things, whether it is flexible pavement or rigid pavement, there will be fatigue. Rutting means it's like, you know, development of holes on top of it because of heavy load. Suddenly if there is huge amount of holes, there will be ruts, cracks developed on it. So that rutting is considered as the failure in flexible pavements, whereas in rigid pavement, mud pumping is considered as failure. What is mud pumping? We will see later. So these are the types of the failure generally you will be seeing in flexible pavements and rigid pavements. So there will be potholes and all those things, the potholes and the other types of cracks and everything comes under rutting only. Fine, whatever the holes, when the vehicle is moving, the cracks, generally you will see all those things comes under ruts only. Fine. So fatigue and rutting generally you will see in flexible pavements. In rigid pavements you don't see cracks, ruts, potholes and all those things. You will be seeing mud pumping. Mud pumping is considered as failure in the rigid pavements. What is mud pumping? I will discuss that. Okay. Any doubts in this? You can ask me. Rupa Kumar, no sir, fine. It's okay, yaar. Only 6 people are watching. Please do like, share, subscribe. Any doubts, guys? Whatever the doubts, if you are having, please go ahead and ask me. Any doubts? No doubts? Thank you. Next one is functions of various components functions of various components of pavement. Functions of various components of pavement. Functions of various components of pavement. The first one would be soil subgrade. Soil subgrade. The first layer, that is soil subgrade. Your soil subgrade, that is your soil. The soil, finally the load will be taken by the soil only, right? Whatever the load that is by vehicles and all those things, finally the load will be taken by the soil only. So that soil, the stresses in the soil should be within the permissible limits. Generally you might be designing in your RCC and geotechnical engineering that what should be the bearing capacity of the soil, and stresses developed should be less than that of the bearing capacity of the soil, right? So whatever the load, finally the load will be taken by the soil subgrade only, soil subgrade, and stress should be within permissible limits. And generally when we are before construction of the road, you should compact the soil subgrade. Compacting can be done by the various methods at optimum moisture content for maximum dry density. So this should be compacted at optimum moisture content. At optimum, what is optimum moisture content, what is dry density, you will see this in your geotechnical engineering. So compacted at optimum moisture content to attain maximum dry density, fine. So if I try to write the points, finally load will be transferred onto the soil subgrade. Right, the load will be finally transferred onto the soil subgrade. So subgrade should be compacted. At optimum moisture content. To attain maximum dry density. Soil should be compacted at optimum moisture content to attain maximum dry density. Before construction of pavement. Okay, next point would be stresses in the soil. Should be within the permissible limits. Fine. Stresses in the soil should be within the permissible limits. So these are the things that you generally consider in soil subgrade. Stresses in the soil should be within the permissible limits, and load will be transferred, all those things. These are the points in soil subgrade. Fine. Next one is subbase and base course. Subbase and base course. These layers are used to transfer the load from surface course to subgrade in flexible pavements. That means in flexible pavement, if you see, subbase and base is provided over here. It is just used to transfer the load from surface course onto the subgrade. That means the load is transferred from grain to grain contact, right? So from surface course to subgrade, the load will be transferred, and the only idea of providing these two things is for transferring the load, at the same time reduce the stress onto the subgrade. That is the only action of this. Whereas here base course is provided in order to avoid mud pumping and also to prevent soil subgrade from frost action. What is mud pumping? What is frost action? We will see. Whereas in flexible pavements, in some of the questions you will be seeing this as sub-base course or base course. Don't get confused. There will be only one course. That course can be called as base course or sub-base course here. Okay. In rigid pavements, not flexible pavements. In rigid pavements, there will be base course that is provided. It can also be called as sub-base course. Okay. This one it can be called as base course or it can also be called as sub-base course. So don't worry about it. In the examination, both means same. In rigid pavements, base course is provided to avoid mud pumping, and prevent soil subgrade from frost action. So in rigid pavements, base course is provided to avoid mud pumping and to prevent soil subgrade from frost action. What is mud pumping? What is frost action? Mud pumping. If you remember, I said there will be certain joints in rigid pavement, right? So in rigid pavement there will be some joints that is present over here, right? In rigid pavement there will be certain amount of joints. During rainy season, water will enter through these joints, and it will mix with the subgrade that is present below. And it becomes wet, right? That whole thing, that soil subgrade becomes wet. So if soil subgrade becomes wet, and whenever the load passes on this, that is plan, this will be cross section. Okay, let us say that is plan and this is cross section. This is some soil. When water passes through this, all these things will become mud, right? That means you are adding more water, then dry density will be reduced. So this will becomes mud, and once this becomes mud, and whenever the load is applied on it, it will try to bend like this. The load will be transferred onto it. During that period, this mud comes out. From the joints. That is called as mud pumping. During rainy season, water goes through the joints, it mixes with the soil and soil becomes wet, and whenever load passes onto the slabs, concrete slabs, then the soil comes out of the joints. That is called as mud pumping. If soil totally comes out of the joints, then automatically the stability will be lost. Once stability is lost, total road will be damaged. That is the mud pumping. In order to prevent this, what we will do is we will provide a base course. We will provide a base course. If you provide the base course, this is base course, generally made up of base course or sub base course, generally made up of both sand and the gravel. So generally made up of fine aggregates and coarse aggregates. So what happens is whenever the water passes, it will be taken by the base course and it can be used for drainage purpose also. Fine, it can be drained. Either it will be drained or only less amount of water will be going downwards, and that can be easily taken by the subgrade. That is the idea. So base course prevents from mud pumping. That is the meaning of mud pumping. Fine. So during rainy season, what you can write over here, during rainy season, during rainy season, water enters through the joint, joints and mix with soil subgrade, to create wet mix, mixes with soil subgrade and forms mud, whenever load passes on the cement concrete course, whenever load passes on the cement concrete course, the mud comes out of joints, this phenomena is called as mud pumping. This phenomena is called as mud pumping. Okay. This is called as mud pumping, and generally base course is provided to avoid mud pumping. This is mud pumping. Next, frosting and heaving, you might be knowing it. Fine. So frost action. During the winter seasons, what happens exactly? During winter seasons, the water present in the soil subgrade, that means if I take this as I mean, it can be seen in both rigid as well as flexible pavements, frosting and heaving action. So water that is present in the voids of the soil subgrade. In the voids there will be some amount of water, right? Water will be present in the voids of the soil. Water will be present. That water will be converted into ice crystals. that water that is present in the soil will be converted into ice crystals. Because the temperature is less in the winter season, it will be converted into the ice crystals. Since it is converted into the ice crystals, the volume increases. If volume increases, automatically cracks will develop, because we are containing it, and if volume increases, what happens? Cracks will develop and generate. Generally, not only in rigid pavements, you will see this in flexible pavements also. Fine, that is called as frosting. Because of frosting, heaving action develops. Heaving means increase in the volume. Fine, and cracks will be developed. That is frosting and heaving action during winter seasons. So what you can write down is, during winter seasons, during winter seasons, the water present in the voids of the soil, is converted into ice crystals. Water present in the voids of the soil is converted into the ice crystals, which in turn leads to increase in volume, that creates heaving. So in winter season, the water present in the voids of the soil is converted into ice crystals, which in turn leads to the increase in volume that creates heaving. Fine, this is heaving, frosting and heaving. Heaving means inertic cracks. You will be seeing either it is in rigid pavement or flexible pavement, you will be seeing it over here. That is frost action. This action can also be avoided if base course is provided. If base course is provided, I can avoid this action also. So base course is provided, this action can also be avoided. This is frosting action. Next one is surface course. Why surface course is provided? Surface course is provided for smooth riding facility and in order to avoid wear and tear. It is provided for smooth riding facility, and also avoid wear and tear. Wear and tear means, it's like, when there is friction between the vehicle tire and the any of the things, tire and the road. Wear and tear means indirectly, because of that the shine will be gone and the friction will be gone, it becomes loose. So all those things are called as wear and tear because of the contact between the tire and the road. Both the the gripness of the tire will also be lost. Tire also will lose its friction, tire also loses its characteristics, tire also loses its shine. That is called as wear and tear. So in order to avoid wear and tear and for providing smooth riding facility, surface course is provided. Right? Constant maintenance and constant keeping of filling of the holes and all those things will be done over the surface course. Generally, in practical, if you ask me, in the villages or in the mandals, in the municipalities, or in transportation terms, if I have to say, in major district roads and village roads, the damages will be seen heavily compared to that of state highways, national highways. Why? Because they deliberately go and dig the soil. They deliberately go and damage the road. Why? So that the people present over there, they deliberately go and damage the roads. Sometimes it's because of the natural calamities or because of the heavy loads, but generally they go and damage the roads so that they can create contract over there, and contractors can construct new roads over there, or for the maintenance works they will go and damage it. Damaging means what they will do, they will just remove the surface course, they will create the potholes, they will remove the surface course so that they can create economy out of it, which should not be done. But majorly in major district roads or village roads you are seeing this. So that is the reason recently government is proposing to construct cement roads and don't put any bituminous course on it. Why? If you are putting some bituminous course on it, they are removing that bituminous course and creating more amount of discomfort for the people, right? So that is the reason major district roads and village roads you will be seeing concrete pavements, whereas highways you will be seeing composite pavements, both like bituminous as well as cement concrete pavement. You will be seeing both. Anyway, so these are the different components that you generally see, and that is mud pumping and frost action. Any doubts up to here? You can ask me. Yeah, you are welcome, Rupak, for things. Any doubts, guys? No doubts? Fine. Please note down properly. Don't think that these nothing will be asked. These are the problems that will be asked in accession reason, and in engineering services prelims majorly you will be seeing these type of questions only. So don't neglect this. Fine. Next one is design of flexible pavements. Design of flexible pavements. Design of flexible pavements. In design of flexible pavements, what exactly? There are different methods. Empirical method, based on physical property, and strength parameters. Based on physical property and strength parameters. First one is group index method, CBR method, California resistance value method. All those things will come under empirical methods, that is based on physical property and strength parameters. And next one is semi empirical and semi theoretical method. Semi empirical and semi theoretical method. Here it would be triaxial method. Triaxial method comes under semi empirical and semi theoretical method. And finally theoretical method based on mathematical calculations. Theoretical method based on mathematical calculations. So here the example would be Burmister's layer theory. Burmister's layer theory. So we will see problems on all these type of things. Each and every method will be discussed, and why I have given the classification is in examination based on whether in accession reason they will say empirical method Burmister's layer theory, that is wrong. Theoretical method is Burmister's layer theory, and all these things comes under empirical methods. You should know what are the empirical methods and what are the theoretical methods. That is the reason I have given this classification. Fine. Next, in this, before going into anything, we will see first design parameters. design parameters. All these things are for flexible pavements. In flexible pavements you will be using IRC 37, and for rigid pavements you will be using IRC 58, 37 2012, 58 2012. Fine. So design parameters. In design parameters, first one is weight of single axle with dual wheels on both sides, standard weight, how much you will consider is generally it will be taken as 8.2 tons, that equals to 82 kilonewtons, that will be nearly 8200 kgs. I have given you this as 10.2 tons in your traffic engineering starting traffic characteristics. I have given this to you as 10.2 tons, but as per IRC, for designing purpose, designing means what? Always idea is to find out thickness of different layers, thickness of pavement, idea is to find out the thickness of pavement. So here generally we are considering 8.2 tons, we will not be considering 10.2 tons, because if you consider 10.2 tons it will become uneconomical. So we will be using 8.2 tons, so that means 4 wheels is of 8.2 tons, means each wheel would be around 2050 kgs. This will also be 2050 kgs. This will also be 2050 kgs. This will also be 2050 kgs. Each wheel is of 2050 kgs. You will be considering the weight of each wheel as 2050 kgs, so that your design would be both economical and strength will also be there. So this is as per IRC 37, as per IRC 37 2012. Remember, this is used for flexible pavements. For rigid pavements it is IRC 58 2012. So weight of the single axle with dual wheels on both the sides will be something like this. Fine. Next one, next point would be stresses developed at the bottom layers, stresses developed at any depth Z, stress developed at any depth Z Fine. If I am saying considering this as tire and this is contact area, if generally this will not be elliptic, this will not be exactly circular, this will be elliptical, the contact will be elliptical, but for our purpose I am taking it as circular. For calculation purpose I am considering this the contact area as the circular, and stress at any depth Z, stress at any depth Z, if I am taking this as theta, stress at any depth Z because of the load P. Let us say the load from the tire is P, because of the load at P, stress at any depth Z is given by, at any depth Z, stress at any depth Z is given by using Boussinesq's theory, Boussinesq's theory. You will be seeing this in your geotechnical engineering. Boussinesq's theory, sigma Z is generally given as P upon pi a square multiplied with 1 minus cos cube theta, 1 minus cos cube theta, where P is the load applied, A is the radius of contact area, P is the load applied, A is the radius of contact area, cos theta is how much? If this is Z, this is A, this will be under root of Z square plus A square, so cos theta would be equals to Z upon Z square plus A square. So cos theta would be equals to Z upon under root of Z square plus A square. This is how you are going to find out stress at any depth Z, which is given by Boussinesq's theory, and how you get all those things, see that in your strength of materials. This is second design parameter. If they are asking, and you can take a note over here, generally contact area is elliptical, but for calculation point of view, for calculation purpose, we consider it as circle. So this is cos theta and all those things. Stresses at any depth Z, and load A is the area, and second design parameter is stress at any depth Z is calculated something like this. Fine. Next one is ESWL. Equivalent single wheel load. In this, what exactly you will be seeing is, if let us say there are two wheels, the distance between two wheels is somewhere around D. And center to center distance spacing, I will be taking it as some S. Then this would be radius is A, this radius is also A. Fine. If I consider this as D, this is A, this is A, this is S. Fine. And load, because of this, I will be taking it as some P. Load from this tire, I will be taking it as P. Let us say at any depth Z, then the load effect will be something like this for this one, okay. So because of the load applied, the load will be distributed like this. This is load distribution. When you are going through the when depth is increasing, the area of exposure is more and stress will be reduced, whereas area of exposure will be increased when you are going downwards. Fine. So this shows the variation of the load, or load will be shared by this much area only over here, whereas this P is shared by this much area at this location. Fine. And if I take this as D, and this will be, I'll be taking it as D by 2, D upon 2. Fine. Here Z depth equals to D by 2. Here depth I'll take it as 2S. I'll be taking it as 2S. Let us say equivalent single wheel load means this two wheel loads is to be replaced by single wheel load such that stress at any location will be same as the stress created by these two wheel loads. That means let us say stress at this location because of these two wheel loads is some 10 kilopascals. Now I'll remove these two wheel loads, I'll keep a single load so that stress I'll replace this by a single wheel load, let us say P dash, that is equivalent single wheel load such that stress at any depth is same as that of stress created by the stress at any depth Z. Stress at any depth Z is same as that of, that means stress over here is same as that of stress here because of these two loads. Stress over here is same as that of stress because of those two loads. Fine. So that means if stress here is 10 kilopascals because of these two wheel loads, then stress here because of this single wheel load is also 10 kilopascals. That is the meaning of it. That means I'll be replacing these two wheel loads such that the stress at any location, strain at any location because of these two wheel loads will be same as that of stress created by the single wheel load at that location. That is called as equivalent single wheel load. And generally the variation if you ask me, it will be logarithmic variation. It would be logarithmic variation, like if Z is less than D by 2, then ESWL, that is indirectly P dash, is equals to P. P dash equals to P. If Z is in the range of D by 2 to 2S, Z is in the range of D by 2 to 2S, then P dash will be in the range of P to 2P. P dash will be in the range of P to 2P. If Z is more than 2S, P dash will be more than 2P. P dash will be more than 2P. So this is how you will be seeing that, and the variation is generally logarithmic variation. It would be something like this. This is log D by 2 and this is log 2S, that is this is log Z thing, and this one is log P. This is log P and this one is log 2. Everything is base 10 only. This is not ln, this is logarithmic variation. If I'll take this as P dash, if Z is less than d by 2, the value is P only. If Z is in the range of d by 2 to 2s, the value would be from P to 2P. If Z is more than 2s, the value would be 2P only. Sorry. What I have given, I think I have given not greater than, the value would be 2P. The value would be 2P. Fine, the value would be 2P. This is how you will be calculating based upon whatever the values that is given to you. You will be calculating equivalent single wheel load. Any doubts in this? You can ask me. Any doubts? Rupak Kumar, I can't see your message. You can type it one more time. And if you are having any doubts, please go ahead and ask me. Even the basic doubts also will be clarified. Any doubts, guys? Fine. So I hope you know what is S, what is D, right? S is center to center spacing between the tires, center to center spacing, center to center spacing between tires, D is clear distance between tires, A is the radius of contact area, radius of contact area. This will be generally 30 centimeters. Fine. So now just take a problem S D 30 12 S is 30 centimeters, D is 12 centimeters. Calculate EWSL. For a pavement thickness of 5 centimeters and 15 centimeters. For a pavement thickness of first one is 5 centimeters, second one is 15 centimeters. Please calculate it. That you have to decide, Narendra, according to the problem. Sir, is it for one axle or both the sides of the axle? Sometimes it will be for one axle, it will be on one side. That means I will be replacing this whole thing. By one single wheel load. I can do that, not an issue. Or sometimes in the problem what I will do is, this is very rare case, very rare case. Generally we go for that only, but if at all they ask, then I will replace this whole thing by single wheel load. But this is very rare case because S is very high here. Generally I said S will be in the range of 30 centimeters, right? 30 centimeters means only this one only, 0.3 meters. That is a long scale thing. So this is very rare case. This is generally what we do. But in the examination, if they ask like S value is like 1 meter, 2 meter, if they have given, you have to take it and solve. So please solve it and give me the value of ESWL. What is the answer, guys? Only 4 people are watching. Fine. What is the answer, guys? What is the answer? How much time you will take? What is the role of pavement thickness? Great. So that means you didn't understand anything. That means at that depth, what is the stress that he is asking indirectly? That means indirectly, if Z equals to 5 centimeters, what is EWSL? If Z equals to 15 centimeters, what is EWSL? That is the meaning of it. If Z equals to 5 centimeters, in the first case, Z depth equals to 5 centimeters. You are providing only 5 centimeters thick pavement. If you are providing only 5 centimeters thick pavement, then what should be the EWSL? So what is D by 2 here? D is given as 12 centimeters, S is given as 30 centimeters. D by 2 is 6 centimeters, Z equals to 2 times S, 2 into 30, that is equals to 60 centimeters. That equals to 60 centimeters. The pavement thickness is what we are more concerned about, right? Don't you think so? Pavement thickness is the one which we are more concerned about. That means he is just saying pavement thickness is 5 centimeters. Pavement thickness is 5 centimeters. On the pavement there will be tires, something like this. So the stress at the end of the pavement, indirectly the stress at this line should be same. Or should be within we are more worried about stress at this line. I told you initially, stress at the soil subgrade should be within permissible limits. So we are more worried about stress at the topmost position of the soil subgrade. This is pavement, that is surface coats, subbase coats, all those things will be here, and this is soil subgrade. Fine, I have to replace these two things by a single load. What is the weight of each load? That equals to 2050 kgs. 2050 kgs. Z is 5 centimeters. That means Z is less than D by 2. If Z is less than D by 2, then what I said, ESWL, P dash equals to P. That is P dash equals to 2050 kgs. Simple. P dash equals to 2050 kgs. Indirectly, I said Z, what I said, that is the depth at which stress should be same. That means indirectly that is thickness of the pavement. At this depth or at the end of the thickness of, at the end of the pavement, stresses should be same. Okay, I think now it is clear to you. Z is the, it can be called as thickness of the pavement, or it is the depth at which stresses should be maintained same. At the end of the pavement, stresses should be maintained same. That is the reason I am taking Z as 5 centimeters. This is first thing, first one. Next one that is given to you is Z equals to 15 centimeters. Thickness of pavement is 15 centimeters. If Z equals to 15 centimeters, that means Z is in the range of D by 2 to 2S, right? That is what you can see, D by 2 is 6 centimeters. Z is in the range of 15 to 60. D by 2 to 2S, right? So if it is in the range of D by 2 to 2S, How exactly you will calculate this? Log 6 log 60, and this is log p, and this is log 2p. We need at what is the value at 15, that is what is the value at log 15. The value is log p dash, log p dash. So you can use linear interpolation method to find out over here. So if I take this as theta, tan theta equals to this upon this, right? Tan theta equals to log 2p minus log p upon log 60 minus log 6. Log 60 minus log 6, that equals to what is this value? Log p dash minus log p, and what is this value? Log 15 minus log 6. Both are tan theta only, this upon this I'll take, and this is log 2p minus log p, right? This upon this is tan theta, and this upon this is tan theta. So this would be log p dash minus log p upon log 15 minus log 6. From this, what is the value of p dash you will get? Try to find out the value of p dash. That equals to log p dash equals to log p plus log 15 by 6 multiplied with log p upon log 10. What is this value? So the value is log log 15 divided by 6 log 15 minus log 6 multiplied with log 4200 minus log 2050 upon log 60 minus log 6. 0.123 plus log 2050 10 to the power of answer. So p value would be somewhere, p dash would be somewhere around 2727.16 kilo Newton. That is ESWL. ESWL. Yeah, so yeah, whatever Prachi has done, that is fine. Any doubts in this, guys? Any doubts, guys? Any doubts? Any doubts? Any doubts, guys? So finally, how I am going to define this as this ESWL, ESWL, equivalent single wheel load, equivalent single wheel load. It is the single load on the tire. It is a single load on the tire which creates same amount of strength, same amount of stress, strain or deflection at any given location, due to the which creates same amount of stress, strain or deflection at any given location, same amount of stress that is generated by multiple loads, at that location. Fine. This is equivalent single wheel load. Any doubts in this? You can ask me. Anyway, it's already discussed. Fine. This is your third parameter. Next, fourth parameter. Fourth parameter is rigidity factor. RF, that is equals to contact pressure CP, upon tire pressure, CP upon tire pressure TP, CP upon tire pressure CP. Fine. So if contact pressure and tire pressure, if contact pressure is more than 7 kg per centimeter square and tire pressure is less than 7 kg per centimeter square, then rigidity factor will be more than 1. That means it is more than 7. This is 8, this is 6. It will be more than 1. And if it is 7 kg per centimeter square, if it is less than 7 kg per centimeter square, this is more than 7 kg per centimeter square, this would be less than 1. That means if this is 6, this is 8, rigidity factor would be less than 1. And if it is both are equal to 7 kg per centimeter square, this value will be generally equal to 1. Sir, what is contact pressure? Contact pressure is generally equals to load upon contact area, P upon pi a square. Load upon contact area, contact pressure equals to load upon contact area, P upon pi a square. Generally this is what you will be seeing. Tire pressure is the pressure developed inside the tire. Tire pressure is pressure developed inside the tire. So don't get confused with tire pressure and contact pressure. Tire pressure is the pressure developed inside the tire. It can be compression, it can be tension, and contact pressure is the pressure developed at the contact. And 7 kg per centimeter square based upon IRC, that low 2050 kgs, and by taking normal, that a value, that is this one. generally that 9 centimeters, radius will be of 9 centimeters. So if you consider that radius of 9 centimeters and 2050 kgs, you will be getting approximately 7 kgs per centimeter square. So based on that, if both contact pressure and tire pressure is same, then it says that rigidity factor is 1. If it is more, if it is less, then rigidity factor keeps on changing. It can be more than 1 or it can be less than 1. These are the things. Fine, this is rigidity factor. Any doubts up to here? Any doubts up to here, guys? Any doubts up to here? Any doubts, please do comment. Now is it clear, Prachi? Now is it clear? Now is it clear? Volume is clear, right? Fine. Next one is, what exactly this rigidity factor shows? Rigidity factor generally shows, rigidity factor generally shows degree of tension developed in the tires. Rigidity factor generally shows degree of tension developed in the tires. Rigidity factor generally shows degree of tension developed in the tires. So that means if tire pressure is low, then walls of tire is under compression. If tire pressure is high, walls of tire is under tension. If tire pressure is high, walls of tire is under tension. Fine. If you take the tire, if tire pressure is more, it expands and it bursts. If tire pressure is less, the walls will be compressed. Fine. So based on tire pressure, we can say that whether the walls is under compression or walls is under tension. Fine. And rigidity factor in turn helps us in finding out what is the degree of tension that is developed in the tires. Okay. And if you see, in designing of the pavements, in designing of the pavements, we are not worried about tire pressure. We are worried only about the contact pressure. Why? Because the pressure that is developed at the contact is the one which will be transferred to the bottom. The pressure that is developed at the contact, if I take this as the tire pressure is the pressure that is developed inside the tire. Contact pressure is the pressure that is developed at the contact. So this is the pressure that will be transferred onto the pavement, right? So while designing the pavement, contact pressure is the one which we are more worried compared to that of tire pressure. So while designing the pavement, or designing means indirectly finding out the thickness of the pavement. While designing the pavement, contact pressure is of more importance is of more importance compared to that of tire pressure. Contact pressure is of more importance compared to that of tire pressure. Contact pressure is of more importance compared to that of tire pressure, TP. That means thickness of the pavement is independent of tire pressure. It is dependent only on the contact pressure. So contact pressure, thickness of pavement, designing of pavement depends only on contact pressure but not on the tire pressure. Okay, and but if you see, contact pressure further depends upon tire pressure only. Based on rigidity factor and tire pressure, we try to find out contact pressure. So both points are correct. That means the designing of pavement depends only on contact pressure but not on the tire pressure. At the same time, tire pressure, but I can say but tire pressure, sir, but contact pressure depends on tire pressure. So if you see both the statements are correct. Okay, so don't think that in the examination if they are given designing of pavement depends on tire pressure, it is wrong. Designing of pavement depends upon contact pressure, not tire pressure. But contact pressure, if you want to find out contact pressure, you need tire pressure. Both the statements are correct, but it's the contact pressure that will be affecting designing of pavement but not tire pressure. So these are some of the tricky things that you generally see. Any doubts in this? You can ask me. Yes, what is the doubt, Prachi? What is the doubt? What should be the rigidity factor? I have given these are the criteria for rigidity factor: greater than 1, less than 1, equal to 1. Generally what I want is, I generally prefer less than or equal to 1. I don't want more contact pressure. More contact pressure means more amount of thickness of the pavement. I try to provide less thickness of pavement. So I prefer less than or equal to 1. No doubts? Fine. Next one is repetition of the loads. Repetition of the loads. Your fifth parameter is repetition of the loads. Repetition of the loads. If you see generally higher loads, that means 8.2 tons, 10 tons load will be very less. That means bigger lorries and the traveling vehicles will be very rarely moving, whereas scooters, bikes and cycles will be moving at very higher frequency. Frequency means more number of times these vehicles will be moving and very less number of times bigger vehicles are moving. So what can I say is, load is inversely proportional to number of axial movements or number of repetitions of the load, where P is the load and N is the number of repetitions of the load. Number of repetitions of the load. P is the load and N is the number of repetitions of the load. P is the load, N is the number of repetitions of the load. So if load is more, repetition would be less. If load is less, repetition would be more. So what you can write is P1 N1 equals to P2 N2 generally. P1 N1, P is inversely proportional to N. Load is inversely proportional to the repetitions of the load. So P1 N1 equals to P2 N2. Generally you can write down this P1 N1 equals to P2 N2, repetitions of the loads. Any doubts in this? You can ask me. So these are the 5 parameters generally we see in designing of the pavements. The first one being have given the what is the amount of the load that we will be taking, 8.2 tons, and if you want to find out the stress, you can find out by using Boussinesq theory. And then we have seen equivalent single wheel load, then we will be seeing rigidity factor, and finally we have seen repetitions of the load. These are the design parameters of the flexible pavements. And today we have seen what is flexible pavement, what is rigid pavement, differences in it, and different types of composite pavement, semi-rigid pavement, and what are the functions of different types of pavements, and what are the failure points, and we have seen design parameters. If I start the group index CBR, it takes more amount of time, so I'll be doing that tomorrow. With this, I am closing this session. In the next session, in the tomorrow session, we'll be solving that group index CBR methods and all those things methods we'll be seeing tomorrow. If you're having any doubts up to here, you can go ahead and ask me. If not, this is Karthik Mandalapu signing off. Have a nice day.